Hey guys, welcome back to the channel. In this video I'm going to be doing a video based on a special request by Sami.Taluri. So he commented asking me to cover a topic called salt hydrolysis. Salt hydrolysis is a nice topic and it links to topic 8 of IB chemistry, and this is to do with acids and bases. It could be topic 8/18, but acids and bases is definitely the topic it links to. So what we need to know is the fact that when a weak acid reacts, its conjugate, right, where CONJ, will be a strong base, right? So a conjugate of an acid is always going to be a base, but when it's a weak acid, it'll be a strong base. So it's all when you look at conjugates in terms of acids and bases, they're always going to be a weak and strong pairing. So if you have a strong acid, its conjugate will be a weak base. Similarly, if you have a weak base, the conjugate will be a strong acid. If you have a strong base, the conjugate will be a weak acid. So next, what we need to think about are cations and anions. So first, let's look at cations, right? So the cation is a positively charged ion. Let's just say M+. What we need to know is that when a base hydrolyzes, when a base forms a conjugate, right? That conjugate will be a cation, right? And when an acid forms a conjugate and hydrolyzes, the hydrolysis will be with an anion. So an acid forms an anion, and a base forms a cation, right? And those formed cations and anions will be the ones that actually undergo this hydrolysis. However, the next component of we need to look at is the strength of an acid or a base. So based on the strength of an acid or base, we can determine the extent at which one of these substances can hydrolyze. So if something is strong, it will hydrolyze. If something is weak, it won't hydrolyze. Okay? So that's how you need to recognize the strength of acids and bases. So with that logic, if we have a weak acid, and we know that the conjugate is a strong base, well, that strong base has to be an anion, right? Because this is the opposite. This is what we form from an acid. We get an anion. So that strong base must be able to hydrolyze quite well. So there would be anion hydrolysis here. Anion hydrolysis, right? And if we have a strong acid, which forms a conjugate weak base, well, there would be an anion because we start off with an acid and we form a conjugate base. However, because this conjugate base is weak, there won't be any hydrolysis. So, no anion hydrolysis. Similarly, if we start off with a weak base and we form a conjugate strong acid, right? We start off with a base, so we get a cation. And we have a strong acid as the cation, so we're going to get hydrolysis. So we'll end up with, let me do this in green, we get cation hydrolysis, right? On the other hand, if we have a strong base and we form the conjugate, it will be a cation, weak acid. However, since it's a weak acid, there won't be any cation hydrolysis. So the key takeaway here is that bases, when they react, they form cations, which are going to be hydrolyzed or not. Acids, when they react in an acid-base reaction, they form anions, which are going to be hydrolyzed or not. Whether it's hydrolyzed or not is based on whether it's strong or not. Strong, yes, hydrolysis. Weak, no hydrolysis. Now let's really look at an example that can help us solidify our understanding. So in this reaction we have aqueous hydrochloric acid reacting with aqueous ammonia to form ammonium chloride. So here we start off with this thing, hydrochloric acid, which we all know is a strong acid. Next we reacted with a weak base, which is ammonia. And then we get this salt, right? So this right here is going to be the salt. So when we refer to hydrolysis of a salt, a more specific definition you could give is reaction of a salt with water to form an acid or a base. Or a base, right? It depends on what it is, like whether it's a cation or an anion, but this is a solid definition for an exam. So since we get this salt NH4Cl, we need to recognize which one's the anion component of the conjugate and the cation component of the conjugate. Well, we have hydrochloric acid to start off with, right? So remember, with an acid, we have to look at the anion component, which is the Cl minus. So this Cl minus is going to go to this ammonium chloride Cl minus, and it's still Cl minus, so that's going to be the conjugate base. Since it's a strong acid, the conjugate base is going to be a weak base, right? So this is going to be a weak anion, so there will be no hydrolysis. Right? And if we look here, ammonia is a weak base, so ammonia's conjugate acid, because ammonia is a conjugate base, it has a conjugate acid, which has a strong cation, which is the NH4+, so there will be hydrolysis. So that's an example where you can really identify whether a component is going to have cation hydrolysis or anion hydrolysis. So in this example, we would consider this as having cation hydrolysis because we have a strong cation. There won't be any anion hydrolysis. An anion hydrolysis example would probably be one where there's a weak acid plus strong base, right? Now, that will give us anion hydrolysis. Now you may be wondering, what if there's a strong acid and a strong base? Well, the conjugates are going to be a weak acid and a weak base. So let me just write this down. Strong acid plus strong base. That's going to give us no hydrolysis because the conjugates of these are going to be weak, so they won't undergo reactions with water. So other than that, guys, this is going to be the end of the video. I hope you guys learned something new about salt hydrolysis. Make sure you like and subscribe. Special shout out to Sami.Taluri for asking me to post this video. And like I said, if you guys comment down below a topic, I'll be happy to cover it in future. So thank you for watching. Like, subscribe, comment. See you guys later.